All right, so we're going to start talking about JavaScript at long last. I know this is a topic that has been on a lot of people's minds, especially as you get into designing your app and stuff like that. And for those of you who don't recognize him, the person in the photo here is, of course, Brendan Eich. He was the engineer at Netscape who is credited basically as the creator of JavaScript. And he's remarking here on the process that led to JavaScript's turbulent birth. And he says, JavaScript had to, quote, look like Java, only less so, or be Java's dumb kid brother or boy hostage sidekick. Plus, I had to be done with it in 10 days, or something worse than JavaScript would have happened. So that's the perspective from the person who created the language. And indeed, the JavaScript experience, JavaScript sort of very quickly got a bad reputation as a language. I'm going to argue that it doesn't necessarily deserve that reputation, but there are ways to misuse it. And part of our goal is to make sure that you learn the ways to use it wisely. So here's where we're going with our overall JavaScript coverage. In general, what are the moving parts that are required to enrich the user experience of SaaS apps with JavaScript? We are also going to talk somewhat about single-page apps and things like that, not really very much about full server-side JavaScript like Node.js apps. And I'll comment a little about why that is shortly. And what's the sort of minimal set of concepts? In this class, I think you figured out we're fans of trying to figure out the 2 or 3 underlying concepts from which you can extrapolate why a framework is the way it is. So we're going to try to identify, for the case of JavaScript, what are the concepts that explain how all these things work. And as it turns out, you already know a lot of the concepts because they map directly over from what we've been doing on the server side with Rails and SaaS architecture. So my hope is that you'll be pleasantly surprised at how few new concepts you have to absorb in order to start doing not just JavaScript programming, but high-quality JavaScript programming. Before we jump into it, let me get my own biases out of the way, because everybody's biased about language things, and I'm usually pretty bold about expressing my opinion. So this will allow you to separate my opinions from fact. JavaScript, I think, does not fully deserve its bad reputation. In fact, Brendan Eich originally, when he was told, we need a language for scripting stuff in the browser, he wanted to put Scheme in the browser. If he had had his way, and that would have been the embedded language for browser scripting, because he thought there was really important, beautiful, great ideas in Scheme, and I happen to agree. And as it turns out, some of those important ideas survive in JavaScript. But at the same time, because there was sort of a marketing push to make it Java-like and to sort of capitalize on the then success of Java, it ended up inheriting some features that get in the way of that as well. Surprisingly, we think our exposition of JavaScript in the book is pretty good. I would say if you only ever read 40 pages in your life about JavaScript, you could do a lot worse than reading these 40. Part of it is that a lot of JavaScript books out there are sort of aimed at non-programmers. They're aimed at people who've been doing web design but don't have programming experience. So on the one hand, they start out with this is a for loop, this is what a variable is. And then they get into sort of very bad coding habits early on. They don't talk about modularity. They don't talk about maintainability. So we're trying to present practical JavaScript stuff, but within this framework of you're trying to write beautiful, maintainable code, and what are the best tools and techniques you have to do that. I'm opinionated about frameworks, just like we believe Rails is the best way to teach people how to build server-side apps. We also think jQuery is the way to do client-side JavaScript. There are other ways, but hopefully we'll convince you that jQuery is to the JavaScript world as Rails is to the Ruby world. It's a framework that really makes so many things easier, you'll wonder why you would have ever gotten along without it. TDD is just as important for JavaScript as it is for the server side of the app. So we'll talk about Jasmine, which is a tool that's relatively new for doing TDD in the JavaScript world. And again, given your familiarity with RSpec, you'll be surprised, I hope pleasantly, about how little you have to learn. All the concepts map straight over. In fact, Jasmine was deliberately built to resemble RSpec, not only in terms of concepts, but even in some of the terminology that it uses. And lastly, server-side JavaScript. Every once in a while, I have a conversation with somebody who says they're convinced that frameworks like Node.js, which is a JavaScript server-side framework for implementing the parts of the app that we've been doing in Rails, they're convinced that that's the way that things are going to go, that all server-side programming is just going to be done in JavaScript. And I ask, well, why is that the case? Why do you think that? And they say, well, because JavaScript is already the browser programming language. So if you're writing the client in JavaScript, why not write the server in JavaScript too? And I'm baffled by that answer. It's like, well, you eat a banana for breakfast, so you should always eat a banana. I mean, there's no logic, right? The part of the software point of view is that you use the right tool for the job, and that means you have to learn a lot of tools. So I think the jury is still out on server-side JavaScript. It's not something we're really going to cover, but I'll talk a little bit about, in terms of perspectives and the differences between JavaScript and Ruby as languages, why I think that JavaScript is not necessarily the best choice in terms of developer friendliness for doing server-side apps. So we'll start with a little bit of history. In 1995, Netscape was on its way to declaring that it was going to make Microsoft go away and become irrelevant. We all know it didn't quite work out that way. Instead, they got absorbed by AOL and Time Warner, and they built a big building in New York, and then everything went bankrupt. But at the time, Java was becoming very popular. Netscape knew they needed some language that would allow people to extend what you could do in the browser. And in part, one of the things you wanted to be able to do is people were embedding Java applets. You needed some way to communicate information between the Java applets and other stuff in the browser, like the other content on the page. So originally, they started developing this language called LiveScript. And like I said, Brendan Eich really wanted to do something that was more like Scheme, but the directions he got were, no, Java's becoming popular, people understand Java, make it kind of look like Java. So syntactically, it kind of does look like Java, and that's the similarity, that the name and a little bit of the syntax. Other than that, JavaScript is actually much more like Ruby than it is like Java. The one important piece of sort of glue that was the thing that Netscape was really after is they had to come up with a representation of the HTML page. And that was the document object model, which we're going to talk quite a bit about today, because that was a way that you could write programs that could manipulate the elements on the page. So the document object model really is what drove a lot of this, right? Here's a way to represent as a set of data structures the thing the user is seeing so that you can inspect and modify those data structures, not only as part of interacting with Java applets, but also later on so you could write your own code, sort of script the browser to do interesting things. In 1997, it became standardized as ECMAScript, which always sounds like a skin disease or something to me, but that's what it's called. So technically, what we're learning is ECMAScript. JavaScript is a variant of ECMAScript. If you know about Microsoft's JScript, that is another variant. And in fact, things like ActionScript, which is used by Flash, are also descendants of or related to ECMAScript. But everybody else calls it JavaScript, so we're going to call it JavaScript. In 1998, Microsoft did a really important thing. They added a single method to the JavaScript API seen by the browser that completely changed how you could do interesting apps just in the browser, and that was XML HTTP request. We're going to talk a good deal about that as well. I'm probably going to call it XHR for short, but the high order bit you need to remember about that is for the first time, it separated the idea of getting content from the server from the idea of rendering the content. So up to that point, every time that you did a request to the server, you would get back something to render, and that was the loop. You would do a page request, and then you would render the content, like reload, refresh, redraw the whole page. XHR separated those two things. It allowed you to write JavaScript that would make requests to the server in the background without changing what was displayed, and then when you got a response from the server, you could decide what to do with that information. So when we talk about AJAX, we'll talk about using XHR. And then in 2005, in my opinion, I think Google really upped the ante. When Google Maps came out, I don't know how many people remember, compared to the other mapping websites of the time, it was like, it was a whole new level, right? You could drag the maps around, and the zoom was interactive. And they had done it by doing really, really good use of these JavaScript capabilities. And AJAX, which is asynchronous JavaScript in XML, kind of took off. So we're going to be talking about how to enhance the client side of SaaS apps primarily. We're going to be talking about what some people call single-page apps. These are apps where once you've done the initial page load, you rarely or never do another page load. And in fact, Pivotal Tracker is an example of this, right? Once you load the initial page with all of your stories, virtually all of your interactions can just stay on that page, unless you want to do things like modify your account or something like that. And within the single-page app category, we can distinguish those that rely heavily on the server and those that don't. So Tracker, even though all of the interaction feels like it's client-side, because you never see the page getting sort of redrawn, obviously your stories are getting stored on the server. And when you do searches and other things like that, that all causes communication to the server. So even though the interactive experience is client-side, it is really a server-centric app, but with a single-page API or a single-page app user-facing front end. And there's also this simple Sudoku app, which you can click through offline if you want. It's basically a Sudoku game that runs in your browser. It's 100% browser resident, so once you've loaded it, you could disconnect from the internet and play, right? That's not true for Tracker, obviously. There's also standalone rich client apps. When Google Docs came out, which formerly was a startup, I think, called Writely, that was sort of another, wow, you could do something that's almost kind of on the order of a simple word processor and do it entirely in the browser. And of course, Node.js and other frameworks like that, where people are now writing the SaaS side of the app in JavaScript as well. So we're really going to focus on these. It's not that the other ones are less important, but given, I think what we're going to learn about these two categories will get you a fair amount of the way to get started if you want to work on the other ones. One thing that we're going to keep in mind when we're doing this is this idea of graceful degradation. So what that basically means is if you have a JavaScript-enabled site and it's being run in a browser where JavaScript is disabled or where JavaScript is incompatible, so like as of last year, maybe 60% of internet browsers in China were still running some variant of Internet Explorer 6, which has a lot of issues with JavaScript compatibility. So people might run into trouble with JavaScript, and you should always have a way that your app is usable. Even if your app was designed to work with JavaScript, you should get a usable experience without it. It should not be the case that JavaScript problems prevent your app from being functional at all. And as we'll see, it's fairly easy to do this if your app is RESTfully designed to begin with. One trick that we're going to use a lot for this is whenever we have page elements that are only meaningful in the presence of JavaScript. So for example, a certain control that when you interact with it causes some JavaScript to execute, and in the absence of JavaScript it would just do nothing. What we'll often do is we will conditionally add those elements using JavaScript code that's loaded at runtime. So a static page, or a browser that just loads the static page and has no JavaScript, because it won't be able to create those elements, they'll just be invisible. So this is one of the standard ways that you can get graceful degradation. And as a preview of where we're going with some of this, we're going to be talking a lot about the document object model. This is a lovely, largely puke and olive colored diagram. I don't even remember where I got it. But basically what I'm trying to represent here is that this is supposed to be a language-independent hierarchical representation of an HTML or an XML document, semi-structured data. The language-independent part is important because most people think of the DOM as being a JavaScript thing, and it's really not. The idea that the DOM has a certain structure and that there's certain properties that have to be true about certain types of nodes, that's language independent. And then different languages have different bindings to the DOM, different ways that you would represent it as data structures in that language. By far the most widely used of those, of course, is the JavaScript bindings, and those are the ones we're going to be talking about. But keep in mind that the DOM really is language independent. So when the browser receives HTML or XML from a server, it essentially parses that into a set of in-memory data structures, in this case accessible from JavaScript. And there's functions that the browser provides that are collectively called the JSAPI, or JavaScript Application Programming Interface. This is a set of functions that are callable from JavaScript and data structures that are visible to JavaScript, but that are really provided by the browser as part of JavaScript's runtime environment. So again, JavaScript as a standalone language is really designed to be embedded in something. If you embed it in a browser, the browser provides a certain set of functions and objects that allow JavaScript to be useful in a browser setting. So for example, it makes the DOM available. If you embed JavaScript instead, like in the server side, then the kinds of things that would be useful to have are really convenient abstractions for doing I/O and system calls, for example. So you could write things like web servers in JavaScript. Because the DOM data is available to JavaScript, that means that you can inspect the properties of elements, you can inspect their content, their attributes. The bad news is that the DOM is implemented fairly incompatibly across most browser types. And when you hear people talk about problems with JavaScript compatibility, 9 times out of 10, it's not the language that's the problem. It's something about the way the JSAPI is implemented, how the browser handles certain calls. We're going to work around that by using jQuery, which is not only super awesome because of the new things that it adds to the functionality we can use, but because it sort of homogenizes the incompatibilities and gives a nice uniform API that works quite reliably across browsers, even for doing simple stuff that the browser would support all by itself. So kind of, the higher order bit here, JavaScript is just a language. The JSAPI is really what gives you the ability to use it usefully in the browser setting, one of the components of that being access to the DOM. And JavaScript is single-threaded. This is important because it's going to make, it'll help understand why some of the JavaScript AJAX interactions are designed the way they are. JavaScript is a language in which there's one locus of control. There's no notion of threads. There is no concurrency. There is no parallelism. There is a single JavaScript thread, and if that thread is blocked, the browser's UI stops responding. So keep this in mind. And people talk about, well, what about things like web workers and these other abstractions for parallelism in JavaScript? Those are abstractions that are outside the language, right? If you think about Java with keywords like synchronized, Java as a language has abstractions for concurrency and for talking about what happens when, let's say, 2 threads try to access a variable at the same time. JavaScript as a language has nothing like that. So there are frameworks people have developed that make it possible to run multiple JavaScript processes or threads in parallel, but there's no machinery in the language itself for talking about things like mutually exclusive data access in those cases. And at any rate, because we're going to be focusing on client-side JavaScript, which is code that runs in the browser environment, we won't be dealing with that at all. We're going to be doing strictly single-threaded. So let's wrap up JavaScript's privileged position, and then we can get into the language. Because JavaScript is the language that is embedded in all browsers, right? That's kind of the de facto standard now. JavaScript code can be triggered. It has access to the DOM as well as, we'll see, to events that the user triggers. Like when the user interacts with page elements, JavaScript can decide to handle those events. It can make HTTP requests to the server. And because of the XML HTTP request method that was originally added by Microsoft, it can do that without triggering a page reload and redraw every time it talks to the server. So that allows you to update things in place. It can be triggered by network events. So as we'll see, when you make a request to the server, because JavaScript is blocking, it's single-threaded, you can't sit there and wait for the server's reply. Because if you did that, the entire browser UI would freeze. So what instead happens is when data starts to come back from the server asynchronously, the browser will essentially wake up your code and say, here's some stuff from the server, what do you want to do with it? So because of the JSAPI bindings, JavaScript can also be triggered, or it can be called into action when network events occur. And of course, it can examine and modify the document object model on the displayed page, which allows you to do the rich apps like Google Maps and everything else that has been built around JavaScript. So let's kind of wrap up our introductory session with a question about client-side JavaScript. It can interact with HTML page elements because, A, it's part of the JavaScript language that it can do this, B, it's part of the browser that it can do this, or C, it's provided by the functionality is provided by the JS API. So which of those three statements is or are true about the functionality of JavaScript code being able to interact with HTML page elements?